Hello there, and a very warm welcome to this week's quick tip. So this quick tip is offset by 1 day. I hope you don't mind and enjoy the show. Let's carry on. This quick tip is about baking textures in Octane. For those of you who are not familiar with baking, as you probably are familiar with the word baking from cooking, it's essentially doing the same. So if you have a dough and have not baked it yet, it is sort of shapeable and can inherit different forms. But once you bake it down, it is in one stiff form factor that you can take with you, and it usually won't break. This translates very well to 3D, so basically you are storing fluctuating or loose data. For example, a simulation is looking differently every time you run the timeline, but if you baked it down, it looks the same. And the other use case is to save on computation. For example, in games, a lot of stuff is baked down, so your computer does not have to compute it, but then just have to read in the pre-calculated data and use it. Usually with baking processes, there's the consideration between compute expense and storage expense. So if you bake something, you take away the load of computation, but you add the load of storage to your system. This is especially true for simulations such as fluid simulations, for example, where the VDB files you save out can be rather huge. But back to topic now, we are talking about texture baking. So let's get started here and jump into Octane. Welcome to Cinema 4D and Octane Land, where we have our Teapot scene that I've created especially for this tutorial. Now, what is it about the Teapot? Let's play the animation real quick. I have a deforming mesh of the Teapot jumping. So it's not a thing that you usually see from me, but I rather like it and I'm rather proud of it because I'm not an animator. I have to say that a lot of my tutorials, or quick tips as I call them, are rather niche, and I think so is this one. Baking textures is not usually needed that much, especially not if you're doing hard surface like I am. And this is also the reason why I did this animation, because it has some deforming meshes. I would say that usually this is a problem that mostly character animators or character texturers would encounter. Since I'm not one of those, I made it a little bit more simple with a teapot instead of a character. And as the saying goes, knowledge is power. I think the more you know about Octane, the better you can use the tool, whether you want to render a character or a hard surface object. It can be beneficial from time to time if you're in the right situation for it. But before you all fall asleep from me talking, let's actually show something and make a material. So let's go to materials here in the Octane Live Viewer under create and create a glossy material. Here we go. And let's call this Teapot. Then go over to our node tree, and if it doesn't show up, then just click Get Active Material here. And what we also want to do is to assign that on our teapot and on our teapot lid. Let's select our teapot and over the object manager hit S so we can see it in the drop-down here. So we see that our material has successfully applied here. What you also can see is that there is a UV tag or a UVW tag. If I shift double click on it, then the UV manager here opens, and you can see that everything in the scene, or the teapot at least, has carefully laid out UVs. And this is one very important thing that you need to have when baking down textures. Because you're baking down your materials from a 3-dimensional projection down to a 2-dimensional map, and therefore UVs are required. Today, again, I won't go into depth with UV unwrapping, but I will show a little bit more about UVs because it's necessary for the understanding of this tutorial. So real quick, let's switch over to our cube scene that I have open here. To understand what baking is doing, we need to understand the spaces we are working in. So this one here is a usual 3D space, and usual people don't have a problem understanding this. We have 3 coordinates and we have a cube in here. So if we turn the camera, we can see sides of the cube that were formerly hidden from our view because of perspective. Textures, on the other hand, live in a 2D space. So they can only have 2 dimensions, x and y. Now, this would be a bit counterproductive, calling the coordinates of 2 different 3D systems the same. So what they've done is just keep on referring to the alphabet. So what you have here is x, y, z, and you know that from every 3D program's coordinate system. And they just kept on for the next 3 letters, u, v, and w, to make up the texture coordinate system. And since images, or bitmaps as they're called, only have 2 coordinates, we skip the w coordinates and we are left with the uv coordinate system. And this is how the name came about. Now, since we are dealing with 2 different coordinate systems, one in 2 dimensions and one in 3 dimensions, we need to sort of transform the 3-dimensional points to a position in 2-dimensional space where it makes sense. And this is exactly where the cube here comes in. I have made a small animation here where I unfold the cube into a 2D position where it aligns with a 2D texture space. So once it's unwrapped, we can apply a texture here, and then it stores sort of the coordinates of the 2D plane here, and it can wrap that around back to the original 3D position. And that is the very essence of UV mapping. Back in our Teapot scene, since you seem to have enjoyed that last time, let's create the shader from scratch here. And since I always want you to learn something, let's introduce a new node that is the Curvature node. Here we go. And the Curvature node is essentially the same as the Dirt node, but with a different algorithm. So you can select the concave and convex edges and do stuff with them. For example, build our Teapot shader that we want. So let's connect it to the diffuse here and let's see what it's doing. There seems to be a small bug here with the offset. As soon as I get the number higher and get it down to 0, it's not quite 0. But believe me, it helps. For example, if you want to go to the convexity here and then set up stuff. For example, we want to increase the strength here and also increase the radius quite a bit, maybe to 3. And that will give us a white color on all of the convex surfaces that we can then use for the shader. If you have artifacting around the edges, such as this here, let's go and make this a little bit smaller, something like this. You have to increase the tolerance here to make it go away, or at least a little bit less pronounced. I have to say I liked the 0.5 value here, maybe a little bit less, 0.4, so we have a little bit more pronounced of an area here. Let's duplicate that map here, make sure it's selected, and put that inside of the diffuse and set it to concavity. And let's see how this is looking. Now, I forgot that in the initial texture here, but for all of those, we want to have this only affected on the object itself and not other objects. So for the curvature here, let's increase the radius a little bit and maybe decrease the tolerance a little bit to 0.1. So we can have a map like this. This is good enough for now. Next, I will introduce a noise so we can vary the radius a little bit, so we have some variance in here. As you know me, I always like the Octane noise, so I'm no different here for today and create a Octane noise. So let's real quick put that into diffuse as well. And now comes the interesting part. Let me make the gamma a little bit higher so the noise gets darker and we can see something. So if I go out of my camera here and move around the object, you are able to see that I have hidden the seam of our UVs in the back of the object. which is good. But on the other hand, if the object is moving, at some point you probably would see the seam here. And it's very obvious. We wouldn't need to bake the texture if we just used UVs all the time. But the disadvantage of using UVs here is the seams, of course. So how do we get rid of the seams? Well, I was talking about the UV space and the UV space that has a W coordinate. And the W coordinate is actually the third coordinate that makes the texture space 3D. And for certain textures, you can use the third dimension in the texture space, for example, for noises, because noises are usually a three-dimensional construct. It's just Octane that maps the noises two-dimensional, and we have to tell it to get them to 3 dimensions. So let's do this by going to the projection here, and let's see where we can find a 3-dimensional UV space. And here it is, it's XYZ to UVW. So we are adding the 3 dimensions from our usual 3D space to the texture space here. And as soon as I've done that, actually let's make the noise a little bit smaller now and make that on all 3 coordinates here. You can see the seam is now gone and we have a seamless noise around our object. And this is actually pretty nice. Okay, so now let's make this noise a little bit larger again, because this is too fine detail for our shader here. Let's go with 0.5 maybe, and then use that to drive our radius. And let's have a look how it looks. Okay, but it's a little bit too strong, so what I want to do is get the gamma out back again. So we just have a little bit of variance in our radius to make it look a little bit more organic. So this makes us ready for the primetime shader, so to speak. So I want to bring in a mix and mix in colors here. So let's tidy this up a little bit. Let's begin with the convex curvature here. That is this one here. And pipe it into the mix amount so we have a mask here for the texture 1 and the texture 2. And as the texture 1 and 2, I want to implement colors. And to do that, I'm going to simply use the RGB spectrum here. Let's choose some reddish color so we don't change the hue, but we change the saturation to maybe 65 and the brightness to about 55. And for our other texture, we essentially use the same color, so we can copy it over here. And then just make it a little bit lighter, maybe 80. And maybe desaturate it a little bit to 45. Here we go. Now let's do the same with the concave edges by duplicating the max and bringing in the concave map here. So for our initial map, we want to use what we already did here. And then we want to bring in another color and make this just a little bit darker. So let's go with 25, for example, or even 15. And if it's not showing up in right strength, we of course are able to adjust our intensity, for example, from the curvature map here. And then we can make it a little bit lighter again. Last but not least, to bring this shader home, let's duplicate this noise here. And what we want to do for the last action here is to multiply in a little bit of variance of the overall surface. So I want to get a multiply here. Again, as always, disable the preview. And then I want to get my favorite node, and this is, as you know, the Octane gradient. Get that in and get the noise in. I want to get the noise to be a gamma 2.2 noise to make it a little bit more pronounced. And then adjust the gradient here to be a little bit more on the side as what we want to have. So let's go and actually set the gradients to be cubic to be a little bit more easy ease. Set this to maybe 50 to pronounce a little bit more the light portions here. And instead of black in the dark portions, let's also make this red. And quite a bit brighter, maybe 25 or even more, 75. Of course, there is, as always, a lot more you can do with it, as bring in surface imperfections or, for example, a little bit of bump. The bump part we can do real quickly, so what I usually do is use another multiply. And let's just use that noise with a float texture here and bring it into the noise. And this is a little bit too strong, so let's put it as 0.1 maybe. So you have the imperfections of a handmade porcelain teapot here. Let me real quick tidy up the notes here. Here we go. Now, besides looking at the UV cube, we didn't talk a lot about texture baking, so let's do this right now. For my animation, I've used a FDD object to deform my teapot. So you can see, if I turn that on and play the animation, you can see that I have a vastly deformed teapot here, jumping up. But by deforming the mesh, we now have a problem. And this is because we set the noise to be in a space that is UVW. That means the noise is living in the 3D space. And it is bound to the axis of the object, but since the mesh itself is moving, the mesh is moving through the noise. So let's show you by soloing that noise here, and then moving the teapot back and forth once more. And you can, especially on the front part here, see what's happening here. But also on the body when it squishes down. And finally, we are landed on the topic of today's video, because to prevent the noise going through the object, we need to somehow bake that. So let me go through the process. I will just disable the FDD again because we don't need to see it all the time. As I've said before, and I can't stress this enough, you really need non-overlapping UVs for baking to work. If it's not the case, then baking won't do anything useful for you. The way you bake in Octane is by creating a baking camera. So let's do this by duplicating our camera, because it already has an Octane camera tag here. And let's go inside of the camera tag, and inside of the camera type, instead of thin lens, you can choose a baking type. Let's also call the camera baking to not cause any confusion. I know this might be a strange concept because our camera in our viewport still looks like a normal camera, but we are not looking through the camera anymore. It is just an object that is in the scene to hold the tag, because right now we are baking our UVs. The reason why you don't see that is because we are not inside of the camera. So let's do this. And you can see a very strange thing is happening. So what's happening here? The camera, of course, as in the real scene, is seeing all the object and all its UVs, and therefore creating all the patches on top of each other. So how do we control that a little bit better? Essentially, as always, with a Octane object tag. So let's create an object tag, and let's go to object layer here. And if you look closely, you can see there's a bake ID. If we want to separate some objects from others, we want to use different baking IDs. And basically, those are all the objects that don't have a specifically assigned ID to them. So let's assign the ID 2 to the teapot. And you can see it's missing now here. So if I only want to show the teapot, let's go to our camera here again. And you can see there is a baking group ID as well. So let's set this to 2. And voila, you have now the baked UVs of the teapot. Basically what we are seeing right now is the noise because it's solo. So let's unsolo that noise here. And now you can see the teapot texture with shadows and reflection and all. There might be times when you want to bake the shadow with the object, but right now we just want to bake the color. And there's a very simple trick to do that. To get rid of your shadows and reflections, just go over to your Octane settings and go to the kernel and set this to info channels. And make sure it's set to diffuse filter. And this is doing what it says. It just gives you the diffuse without shadows and reflections. And this is exactly what we want. Small word of caution here. The ray epsilon can be different per render kernel. So make sure the ray epsilon is the same as in your main scene here. One thing I always do is increasing the padding size. And this increases the boundary of the colored patches here around your UV islands. So let's do this real quick and set this to 16. This is the max size. So we don't get any errors around the UV islands when we bring in the texture that we've baked out later into the scene again. Last but not least, there are a couple of artifacts here. This artifact is inside of the pot, so I don't care about it. This would be something you could fix with the curvature shader. And then there's this artifact here, and this probably comes from the handle. So let's just disable that and see if that gets better. And yes, it does. So sometimes for baking, it's good to bake objects apart from each other. Otherwise, you might end up with artifacts. So finally, we can go to the render settings and set those up. And those are very easy to do because we don't save anything fancy. We just want to save a 8-bit TIFF file for now. Usually my textures are all 8-bit TIFF files. Those are fine. So let's go to Octane Render and make sure this is set to sRGB. Then let's go to the output and make sure this is set to a square format because the UV space usually is a square. So let's go with 2K here. And last but not least, let's set the slider to frame 0 to bake. Okay, so I think we are done here. And let's see if everything works out as expected. And yes, within a couple of seconds, 5 to be exact, you have baked out your image texture here with the noise and everything that we've set up inside of our shader. Now, what might be important to know is that if we go back to our shader here, you can see that we used one of the noises twice. So one of the noises is just used in the output for the diffuse. But one of the other noises is used for the diffuse as well as for the bump. And the bump needs a different map. So we need to store that or bake that out extra. So let's do this real quick by just piping in the noise into the diffuse and then just hit render one more time. And easy as that, we now have baked out our bump map. Remember that this is needed for every object. So before that, we could just use the same material for our lid and our teapot. But since the teapot and the lid have different UV sets, we need to bake down the texture for every single object. Or the alternative would be to have a combined UV map for the lid and the teapot together. So let's actually do this and make a material for our teapot. Since we didn't save out the lid material, let's just do the teapot. And to be honest, the lid is not deforming at all, only the teapot itself is deforming. So we just need the material for the teapot. To do that, I want to duplicate the teapot material here and maybe mark it with BK for baked. And instead of the node trees here, we can delete all that. We just want to bring in our textures that we've just baked. So let's do this by bringing in an image texture here. And then choose the texture that we've just baked. I know you would have to save that before, but I did that before, so you just have to trust me that the saving process is not very hard to do here. Here we go. So we've added our noise for the bump and our texture for the diffuse. And last but not least, we want to assign that here and then go out of our baking camera and inside of our other camera here and maybe change the aspect ratio back. It would be useful to have a different render setting for that, so you don't have to switch back and forth all the time you want to bake something. And then hit render here. And finally go out of the Octane info kernel into the path tracing once more. And then, last but not least, let's just take the diffuse back into diffuse so our lid is looking right. Also, turn on the handle again and we are there. So if we now go outside of the camera and have a close look at the teapot here and deform it, you can see that the noise is now sticking to the teapot. And with all of that, we also got rid of the seam that was here because our 3D noise was baked down into the UVs and therefore didn't have a seam anymore. And this is basically it. So if you have any seams in your meshes and you want to close them by using a 3-dimensional noise, but your mesh is moving and you have problems with the noise sticking to the mesh, then the baking method is a very valid method to do that. I know in other renderers there are methods to stick the deforming mesh somehow different to the noise, but in Octane it's at least the only method I know of that you can stick your 3D noise to a deforming moving mesh. If you have any ideas for any good tutorials, please let me know in the comments. If you have any questions, also write down in the comments. Hopefully in this tutorial you found something interesting and new. And I think that concludes everything for today. So thank you again very much for staying with me that long. And I say have a good time and happy baking. Bye!